Well, hello everybody. This is a Dell Latitude 7310 that I bought for €50. The person I bought it from said that it is not powering on. So just to demonstrate the fault here, I have the charger plugged in. I'm going to press the power button, and as you see, nothing happens. Power button feels a little spongy, but that's probably not the fault. But as you can see, it's not powering on when I plug it in. Let's take out the motherboard and have a look and see if we can find out what's wrong with this.
Just before pulling out the motherboard, I decided to try the USB adapter in the second USB port. However, when I did, I noticed that it was extremely loose. So I just pulled it completely off the board and confirmed that none of the pins on the board itself were shorted. So we're going to be working with the second port, which is JUSB-C1, which appears to be okay. I'm going to plug into this and we're going to start taking some voltage measurements. And this is what my motherboard looks like when I scan it in. So we're going to start as usual at the DC input. I scanned this before that second USB port fell off the board, so as I mentioned earlier, we're going to be dealing with JUSB-C1. On the schematic, I've found the section that references JUSB-C1. As you can see, it shows us the pin configuration for that USB-C port. Now the ones that we're concerned with here are where the DC input comes in, and those pins are VBus 1, VBus 2, VBus 3 and VBus 4. As you can see here, they all essentially are connected together and they're all referred to as 20 volt underscore TBTA underscore VBus. So I want to locate that further down the schematic and see where we can carefully take a measurement and see what voltage we're getting on that. I located 20V underscore TBTA underscore VBus further down the schematic, and here it is. So you can see the first components that are in line once it comes in on the USB-C port are these two inductors here. So we've got PL806 and PL805. So I think these will provide a good place for me to measure what we're getting on the input voltage, because obviously the pins on the USB-C port are tiny and I'd rather not try to measure on those because I'll just end up crossing them and causing more harm. So I'm going to locate these two inductors and see if we can take a voltage measurement at these. I located those two inductors close to JUSB-C1, so I just want to see if there's any voltage measurement on this, because it certainly could be the case that the second port is broken also and we may not be getting any voltage onto the board at all. So I introduced my multimeter in volts DC in the 20 volt range. I placed my black probe to ground and my red probe to the inductor. When I place it there, I measure 5.10. So we are actually getting 5 volts from the power supply onto the motherboard. Now if we go back to the schematic for a second, you'll see at PL806 where I've measured 5 volts, this is labelled as 20 volt underscore TBTA underscore VBus. Also, if you look up the actual charger itself, it says that it's a 20 volt charger. So I think what's meant to happen here is when you plug in the charger, it's meant to auto negotiate with the PD controller, and I should be measuring 20 volts at this point here. I think the fact that I'm measuring 5 volts here is a sign of a failed negotiation between my adapter and the PD controller. So the next step I wanted to do is check the PD controller and see if I was getting the correct input voltage on that IC. I found that if I followed this path down here, plus 20 volt underscore TBTA underscore VBus underscore 1, this brought me to the input of the PD controller. And further down the schematic, I've located plus 20V underscore TBTA underscore VBus underscore 1, which comes on to pins 13 and 14 of our TPS 65988 PD controller. So these are labeled VBus 1 and VBus 1 2 on this, so it just comes in on 2 pins. If we look up the datasheet for that PD controller, what it says is it's a dual port USB Type-C and USB PD controller with integrated source and sync power path supporting USB 3 and alternate mode. So what does it do? The TPS 65988 is a highly integrated standalone dual port USB Type-C and power delivery controller, providing cable plug and orientation detection for a single USB Type-C connection. Upon cable detection, the TPS 659 and it communicates on the CC wire using the USB PD protocol. So that's where it's meant to negotiate what voltage should be delivered by the power adapter. And if you look down here, we should have a direct connection between each of the USB ports and the V bus. So what I need to check is, am I getting the same 5 volts on V bus 1? So let's do that now. Just a quick note at this section, guys. This is the first one of these dual USB-C with a PD controller type power inputs that I've looked at on the channel. Not because I've been avoiding it or anything, but literally just because all of the other laptops I've got have been sort of significantly older. I have done a crash course in this during the week, but if I've made any mistakes on what I'm doing here, please feel free to put them in the comments below. I'm sure after we do 2 or 3 of these, it'll all become second nature anyway. But if you see anything wrong, please put it down in the comments below. So let's take a closer look at the pinouts on this TPS 65988. I've drawn in each of the pins to make this easier. And if we look up our schematic once again, we can identify the 2 V-bus pins that are related to our 1 remaining USB-C port are on pins 13 and 14. So if I look at pin 13 and 14, you can see that we're down the bottom left, 13 and 14 in the bottom right. V bus 1, V bus 1. So we need to take a voltage measurement right here. So introducing my multimeter in volts DC once again, I place my black probe to ground and I place my red probe to the capacitor that connects the pins 13 and 14. And when I do that, I find that it measures 5.10. So what does that tell us? Well, it tells us that we have a continuous path between the V-bus pin on our USB port and the V-bus input pins on our PD controller. However, even though we have that input, it seems like it's not negotiating to the correct voltage because we should have 20 volts on that input power rail where the inductors are. So what other things can we do to confirm whether this IC is actually working or not? Well, I noticed in the datasheet that there is a mention of a 3.3 volt LDO. Now what it says here is the 3.3 volt LDO from VBus steps down the voltage from VBus, which we've confirmed is 5.1 volts, to LDO 3V3, which allows the TPS 65988 device to be powered from VBus when V in 3.3 volts is unavailable. So what it seems to me here is that there is a 3.3 volts LDO that's generated from within this IC, that it takes the 5.1 which we are measuring correctly on VBus and it should bring it down to 3.3 volts. So let's locate the pin where this LDO 3.3 volts is and see what we're measuring. And back to our motherboard, I can see here that pin 9 is marked as LDO underscore 3V3. So as we've seen from our datasheet, this should be generated from our VBus input voltage, which we've measured as 5.1. So what I need to check is to see if this voltage is present. So with my black probe on ground, again measuring in volts DC, I place my probe to the capacitor that connects to that pin and I find that it measures 1.30. So that's not the correct voltage. We should be measuring 3.3 volts there. So I think that is indicative of there being a problem with this IC itself. Looking back to our data sheet for a second, we can see that there's a second LDO power. There's a 1.8 volt LDO, but this is stepped down from our LDO 3.3 volts. So we've already measured our LDO 3.3 volts and that's not measuring the correct power. So obviously if it's not correct, then our 1.8 volt LDO is also not going to be correct. So there's no point in measuring that. I decided to take some diode mode measurements of the capacitors around this IC in the same way that we would when we were troubleshooting Super I/O. So I introduced my multimeter in diode mode. I switched the power off, obviously, and I placed my red probe and my black probe to the two sides of this capacitor right here, and I found that it measured 0.016. So this is very low. Again, with the power switched off, I took the same measurement at that LDO 3.3 volt and that also measured 0.016 in diode mode, which is also very low. I also measured the same value at this third large capacitor that's beside this TPS 65988. It's also measuring 0.016 in diode mode.
I decided to give my trusty thermal camera a go, and with that power adapter plugged in, the only IC that's warming up is the PD controller.
So the next step I decided to do was to remove the PD controller. So with a bit of patience, a lot of hot air and a lot of flux, I removed it from the board. And through the magic of Photoshop, we removed that IC. So what I want to check now is, having removed that IC, are we still getting the low diode mode readings on this capacitor, and this capacitor? You might remember we were reading 0.016 on all of those. So let's check them now that the IC is removed and see what they're measuring. The capacitor on the left is now giving us a diode mode reading of 0.396 with the IC removed. The second capacitor on the right is also giving us a diode mode reading of 0.396 with the IC removed. And the measurement at the third capacitor, which was on pin 9, that's for the LDO 3.3 volt, we're now measuring a voltage drop of 0.576 with that IC removed. So what can I conclude at this point? Well, what I do know is that with this IC soldered onto the board, I'm getting very low diode mode readings on those three capacitors. When I remove this IC, the readings seem to be closer to what I would expect them to be. I am also conscious that this is the first one of these that I have dealt with on the channel, so I would be appreciative if any of you guys can help me out with whatever experience you can offer in the comments down below. I have looked at a number of other videos in preparation for this, and it seems to be the case that if the technician sees that the 5 volt stays at 5 volts and is not boosted up to 20 volt after communicating with the PD controller, most people seem to conclude at that point that there is an issue with the PD controller. But I'm going to leave it at that for the moment. I'm going to order one of these, I'm going to try and replace it, and we will take it from there. And I'm going to try and buy a few more of these types of laptops so that I can bring the channel forward and start doing more, more advanced sort of stuff and more modern stuff as well. Like a lot of the laptops I've had up to this point have been, more than 3 or 4 years old, and it's not good when I come to a laptop like this that I haven't seen before. And they're all going to be USB-C going forward. I hope you enjoyed the video. Please like and subscribe, and as I said, if you have anything you can contribute to this, or you think I've got something wrong, please put it in the comments below, and I'll see you next week.